Let's start with a question that, sounds pretty simple, but it might be one of the deepest puzzles in all of physics. Is time actually real?
I mean, really think about that for a second. If you had to build a universe from the ground up, what's the one ingredient you absolutely couldn't leave out? For most of us, right, the answer seems obvious. It's gotta be time. Time is the river that carries everything along.
But what if that's totally wrong? What if time isn't the river at all, but just an illusion created by something way, way stranger? That's the wild idea we're going to dig into today, and it comes straight from the cutting edge of theoretical physics. To really get this, we've got to take a trip into the bizarre world of quantum gravity. This is where physicists are trying to write down the ultimate rulebook for the entire cosmos, and it's right there that they slammed into a huge problem.
Okay, so this is it, the Wheeler-DeWitt equation. The easiest way to think about it is like Schrödinger's equation, but not just for a particle, for the whole universe. This is supposed to be the master equation, the one that describes everything all at once.
But when you actually solve it, something incredible happens. Or, well, more accurately, nothing happens. The equation is totally timeless. The variable for time, the little t that you see in basically every other physics equation, it's just gone. The universe, according to its own master equation, doesn't evolve. It doesn't change.
And look, this isn't just some little mathematical quirk. No, this is the central mystery that physicists call the problem of time. How on earth can a universe that feels so incredibly dynamic, so full of change and motion, be described by an equation that's, well, eternally frozen?
So, this puzzle has stumped some of the smartest people on the planet for decades. But one physicist, a bit of the maverick, came along and proposed a radical solution. He basically said, what if the equation isn't broken? What if our idea of time is what's broken?
And that physicist is Julian Barbour. His answer is about as bold as it gets. The Wheeler-DeWitt equation is telling us the literal truth. Time, as we experience it, this flowing, passing river, it just doesn't exist at the most fundamental level of reality.
So Barbour's whole idea starts with a philosophy called relationalism, and it's pretty simple at its core. It just says that the only things that are truly real are objects and how they're arranged in relation to each other. This whole idea of a big, empty stage, a container of space and time, is just a convenient fiction we've made up.
So, if you're a relationalist, what is the universe? Well, it's just a collection of all the possible ways everything could be arranged, and each one of those arrangements is a complete, self-contained, and totally static snapshot, a picture, and Barbour has a name for each one. He calls it a now.
And this image here illustrates it perfectly. Let's say you have a super simple universe with just 3 particles. Well, every possible triangle they can form is a different, unique now. Barbour imagines all of these nows, and I mean all of them, existing together as single points in this gigantic, timeless landscape he calls configuration space. There's no past or future here, just different places in a static geography of what's possible.
Okay, I can practically hear you thinking, this is absolutely nuts. I feel time passing. I remember what I had for breakfast this morning. So how in the world does Barbour's timeless universe explain our powerful, undeniable experience of time?
This really is the crucial question, isn't it? If we are just living in one of these frozen snapshots, one single now, then why does it feel like we arrived here from a past? Why do we have memories at all?
Barbour's answer is this brilliant concept he calls a time capsule. He argues that some of these nows are just special. They are static arrangements that, just by their nature, contain records or information or structures, like fossils or photographs or memories in your brain, that give the appearance of a past. Your memories aren't echoes from a past. They are physical structures that exist right here in this present now.
Let's just break this down because it's a huge idea. Okay, step 1. You only ever exist in one single static now. Step 2, that now includes the physical state of your brain, which holds all the patterns we call memories. And step 3, these fixed, embedded records create this powerful, compelling illusion that you've journeyed through time. You didn't travel from the past. The past is encoded right here, inside the present moment.
So, with this totally new way of looking at things, we can go all the way back to that bizarre Wheeler-DeWitt equation and see it in a whole new light. Turns out, the problem of time wasn't a problem with the math at all. It was a problem with our assumptions about reality.
That equation was never, ever trying to describe a universe evolving from one moment to the next. That was our mistake. Its real job is something completely different. and in Barber's view, something far more beautiful.
So what does it actually do? Well, it acts kind of like a probability map, spread out over that huge landscape of all possible nows. It tells us which arrangements of the universe are more likely to exist than others. The equation just points to the most probable nows. And get this, it just so happens that those highly probable nows are very often these time capsules, the snapshots that contain all the rich structure that gives us this illusion of a past.
Here's another way to think about it. The standard view of reality is like a movie, playing out one frame after another in a straight line. Barber's view? It's like a cosmic museum, where every single possible frame of that movie exists at the exact same time as a static exhibit. And what we call the flow of time is just our consciousness moving from one exhibit to the next.
So if time isn't this fundamental river flowing through the cosmos, what is it? Barber's theory offers a really beautiful and, pretty mind-bending conclusion. In his own words, time isn't a thing in itself. It's something that emerges from the relationships between all those different static nows in configuration space. It's all about how different arrangements of the universe relate to each other, not about some cosmic clock ticking in the background.
And this is the ultimate takeaway. Your past isn't gone forever. Your future isn't some unwritten void. They are just different places in this immense, static landscape of all possible realities. Every single moment of your life exists, complete and unchanging in its own spot.
Which leads us to a final, really provocative thought. If every moment that ever was or ever will be just is, like a country on a map, then where are you, really? And is the you who was a child reading your favorite book just as real right now as the you watching this? In this timeless universe, it's definitely something to think about.